All right, welcome to unit number 7, where we're going to be talking about quadrilaterals. Quadrilaterals are four-sided figures, okay, and there's multiple ones that we're going to learn about the properties and all that good stuff. Today we are starting with parallelograms. All right, so by the end of this video, you should be able to identify the characteristics and the properties of a parallelogram, and then be able to tell me, given those characteristics, if you have a parallelogram in front of you. You will also be able to construct a parallelogram. That is something that you'll be doing during class time, so please make sure this packet goes back. Now, something to be aware of this unit, and I'll remind you as we go on, this first page is not going to be a page that we're going to write on together. This is something that you're going to go back to at the end and fill in on your own. I will reference this towards the end. So I'm going to go ahead and flip to the next page. Okay, so let's start with talking about parallelograms. So first, the definition of a parallelogram. It's a quadrilateral, meaning a four-sided figure, that has two pairs of parallel sides. Okay, that is your definition for a parallelogram. Sometimes just be aware, it's abbreviated with the parallel lines. Okay, not often, but if you just see that somewhere, just know that that is also a parallelogram. That's the word for it. Okay, so let's talk about our properties. There are 5 of them. The first one, opposite sides of a parallelogram are parallel. Okay, so in order for it to be a parallelogram, that this must be true. All right, if I tell you it's a parallelogram, you can also conclude these things to be true. So if I'm looking at this parallelogram here, ABCD, AB is parallel to CD and BC is parallel to AD. Okay, notice that AB and CD are opposite sides. They do not intersect. And we're saying they are parallel, meaning they will never cross each other. So to show parallel on a diagram, we are going to use arrows. Okay, that indicates that those two sides are indeed parallel. They will never cross. And of course, if I'm on a coordinate plane, in order for them to be parallel, that means that the two slopes would be the same. All right, I also see that BC is parallel to AD. So these two sides are parallel. I'm going to use a different color. Now, I can't just draw one arrow and call it a day, because then it would show me that all 4 sides are parallel, and that's obviously not true. Some of them intersect. So to show different set of parallel, I'm going to use a different number of arrows, 2. Okay, it doesn't matter if I use the 2 on the side and the 1 on the top bottom, whatever. All right, it's just showing me, indicating which 2 sides are parallel to each other. All right, so that is one property of a parallelogram. If we tell you it's a parallelogram, you know that instantly that the opposite sides are parallel of each other. Okay, the second property, opposite sides of a parallelogram are congruent. Remember, congruent meaning same measure. Okay, so if I go back to this, ABCD is a parallelogram. That tells me that AB is congruent to CD and that BC is congruent to DA. Okay, so AB is congruent to CD and BC is congruent to AD. Okay, so once again, I'm just marking it on my diagram so you can see that. Also indicating that I have different sets of congruent markings. Now, there are special parallelograms where all 4 sides are congruent. We'll talk about that later. So for right now, we're going to assume that AB and CD are congruent and BC and AD are congruent. Okay, so our first 2 properties, opposite sides are parallel, opposite sides are congruent. Okay, so you could say that BC is parallel and congruent to AD. Those are true. All right, our third property, opposite angles are congruent. Okay, opposite angles are congruent, same measure. So angle A is congruent to angle C. So if I tell you angle A is 30 degrees, what's the measure of angle C? If you said 30, you are correct. Okay, and angle B is congruent to the measure of angle D. Okay, opposite angles, meaning they don't touch each other at all. Okay, they don't share a common side. Opposite angles are congruent. Okay, recap. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Those are your first 3 properties. So once again, if you're told something is a parallelogram, you can conclude all 3 of these things to be true. Likewise, we're going to talk about how you go the other way. If I give you a diagram and show you if sides are parallel, congruent, whatever, you can conclude that if it is a parallelogram indeed. So we can go both directions. All right, let's flip to the next page. Okay, we have two more properties to look at. Actually, before we do that, go ahead and try this. So knowing that opposite angles are congruent, if I tell you that the measure of angle 1 is 48, the measure of BCD is 70, you need to find me the measures of those other angles, okay? All angles in the triangle. I'm sorry, in the parallelogram. So please go ahead and pause your video, read the hint on the side to help you. I'm going to pause mine as well and go ahead and do the work, and then we'll talk about it in just a moment. So please hit pause. All right, let's take a look. What I did was I started by labeling the angles that I knew in green. I know that the measure of angle 1 is 48. I also know the measure of BCD is 70. Now careful, BCD is that entire angle. It's the 3 and the 4 together, okay? So where did I go from there? Well, I knew that BCD was going to be the same measure as BAD because opposite angles, so they're congruent. So if BCD was 70, that means BAD had to be 70. So this whole thing I'm outlining right now is 70. Okay, from there I could actually find angle 2. Because if this whole big angle was 70, I could have subtracted 48, and that is how, and 48 was given to me, that's how I got the 22. Now, if I notice, if this is a parallelogram, these two sides are parallel. So that makes angle 2 and angle 3 alternate interior angles. It also makes angle 1 and angle 4 alternate interior angles. Think way back to the unit on angles. What is true about the measures of alternate interior angles? They're congruent. Okay, so if 2 is 22, that means 3 is 22 also. If 1 is 48, that means 4 is 48. And of course, to find the third angle, the B and the D, I can use my triangle property. Here's a triangle. These three angles have to add up to 180. So 22 plus 48 is 70. Subtract that from 180, and I got my 110. Okay, I can do that 2 times or realize that B and D are congruent because they are opposites. So notice, looking big picture, I've got 110, 70, 110, 70. And then my 70s got broken down. Now, take a look at that. Look at angle B. The measure of angle B is 110. The measure of angle C is 70. What is the sum of those two measures? Angle C is 70 and angle D is 110. What do those add up to? Angle D is 110, angle A is 70. What do they add up to? Are you starting to notice something? And that will lead us into our next property. Consecutive angles, meaning angles that are next to each other, they share a side. They're supplementary. So consecutive angles add up to 180. Okay, looking at my diagram, A and B add up to 180. They're next to each other. B and C add up to 180. So these two. C and D add up to 180, and then A and D add up to 180. Okay, any two angles next to each other in a parallelogram add up to 180 degrees. They're supplementary. Going back to this diagram, I could have used that to help me. Okay, if I knew that. If I knew that this whole big thing was 70, I just subtracted that from the 180 to get my 110. Okay? So consecutive opposite angles are congruent. Consecutive angles are supplementary. Pause the video, try this. I'm giving you one angle. Use those two concepts to fill in the other three. Please pause your video. All right, take a look. If angle R is 112, that means angle T has to be 112 degrees as well because they're opposite angles and they're congruent. It tells me right here. All right, and then I knew that consecutive angles are supplementary. So 180 minus the 112 gave me the 68. Okay, and then those two are congruent because they are opposites. So I can use, if I have one angle measure, I can find all the others. Now, if you were to add up all four of those, please notice this right here. In a quadrilateral, all the angles add up to 360 degrees. And if you think about it, it makes sense. What is the sum of the interior angles in a triangle? 180. If you notice up in this diagram, when we drew a line down the middle, we made two triangles. So if I have two triangles, 180 plus 180 is 360. Okay? All right, let's go ahead and take a look at the last page. We have one more property to talk about. I didn't mean last page, I lied, sorry. All right, opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. The last thing we're going to talk about are the diagonals of a parallelogram. The diagonals being the lines that connect the opposite angles. So as you notice, I drew a line from A to C. I drew a line from B to D, and where they intersected, I just labeled it E, so we had a reference point. Okay, so the opposite, or I'm sorry, the diagonals bisect each other. Bisect meaning cut in half. All right, so if ABCD is a parallelogram, then BE is congruent to ED, meaning this diagonal BD is cut in half, meaning those two pieces are congruent to each other. Likewise, the diagonal AC got cut in half, so AE is congruent to AC. I'm sorry, to EC. Okay, that is the last property we are going to talk about with parallelograms. So if you are told this is a parallelogram, you should instantly be able to tell me those 5 things are true. You can tell me their diagonals are cut in half. You can tell me the opposite sides are parallel and congruent. You can tell me the opposite angles are congruent, and you can tell me the consecutive angles are supplementary. Okay, so we are going to use that information now to solve problems, and then we will also use that to help us identify whether or not a diagram is a parallelogram, so going the other way. Okay, so when do I know a quadrilateral is? So that's what I was just talking about. So if the diagonals of a quadrilateral bisect each other, it is a parallelogram. So go in the opposite way. Once again, I told you a parallelogram has diagonals that bisect each other. So if you can show that the diagonals bisect each other, you can tell me it is a parallelogram. So let's take a look at this problem. It says determine the value of the variables for which L, M, and P is a parallelogram. If LO equals that, ON equals that, blah, 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 find me the variables at work. Well, we know, we're going to do this one together, we know that the diagonals have to bisect each other. So what we're going to say is we're going to put LO equal to ON and solve for Y. We're finding out what number, sorry, it's a minus, what number for Y is going to make those two indeed equal to each other, which will make it a parallelogram. Likewise, for X, I'm going to put MO equal to OP. And I'm saying that if they are truly, it is truly a parallelogram, I can find a number that is going to work so that the two sides are equal to each other. Okay, please pause the video and solve these two on your own. Okay, so I got y to equal 12 and I got x to equal 5/2 when I solved my equation. So if you can show me that the two diagonals are truly cut in half, then you can show me that that is a parallelogram. And of course we know that we could go back in just to prove it and plug in my 12. So 2 times 12 is 24, minus 8 is 16, so that's 16. And then y plus 4, 12 plus 4 is 16. Okay, so that is truly cut in half. Likewise, the x is 5/2. 3 times 5/2 is 7.5. And then 2.5 plus 5 is 7.5. Okay, so I showed a number that works to make the two diagonals cut each other in half, meaning that is a parallelogram. Okay, other instances that work. So there's 5 different scenarios that work. It's going backwards of what we just did. Okay, so if the diagonals cut each other in half, they bisect each other, it is a parallelogram. If both pairs of opposite sides are congruent, the quadrilateral is a parallelogram. So once again, you're working backwards. What I'm saying to you now is if you can prove that BC is congruent to AD and that AB is congruent to DC, then it is a parallelogram. Okay? So we're saying if AB, that's a B, is congruent to CD and AD is congruent to BC, then we are concluding that ABCD is a parallelogram. Okay, and that's reverse of our first property. Next one, if one pair of opposite sides of a quadrilateral, actually let's come back to that in a second. Let's go down to the one below it. If both pairs of opposite sides of opposite angles of a quadrilateral are congruent, it's a parallelogram. So if you can tell me that angle A is congruent to angle C, and you can tell me that angle B is congruent to angle D, then you can tell me that, yes, it is indeed a parallelogram. Okay, so you may be given a shape and given information, you have to decide, is it a parallelogram? Let's go right next to it. If both pairs of opposite sides of a quadrilateral are parallel, then it's a parallelogram. So same thing. If you can tell me that BC is parallel to AD, and you can tell me that AB is parallel to CD, then you can tell me that ABCD is a parallelogram. Last one. If one pair of opposite sides of a quadrilateral is both congruent and parallel, it is a parallelogram. So if you can tell me that AB and CD are parallel and congruent, it is a parallelogram. Because what that will mean is that the other side has to be parallel and congruent as well. Okay? Because if they're the same, if they're going the same direction and they're the same length, then they're going to stop at the same point. Okay? Making the other two. So if you can tell me that AB is parallel to CD and AB is congruent to CD, or you could insert the other two. You could say BC and AD. That's fine, as long as one pair. Then you can conclude it's a parallelogram. All right, so guys, we just took those 5 facts that we learned, the characteristics, and we went the opposite direction. We inverted it, okay? As opposed to me saying, hey, it's a parallelogram, so this is true. We looked at information given and said, hey, well, if that's true, then it must be a parallelogram. Okay, try this on your own. Please pause the video. Decide if the graph or if the shape given to you is a parallelogram and why. So even if you say no, you must tell me why. Okay, there's just the 3. Do not do the in-class lesson. You will do that in class. Please pause the video while I pause it as well. All right, take a look. A and C are yes, B is no, and let's take a look at why. Okay, in example A, I see that I have one pair of opposite sides that are both congruent and parallel, and we said that is enough, a bare minimum that we can prove that that is a parallelogram. Okay, if one pair is both congruent and parallel. In B, I don't have enough info. Okay, I see that I do have a pair of opposite sides that's parallel, but the other pair is congruent. It has to either both be parallel, both be congruent, or one pair is both of them. Okay, because as you see, I drew an example that it won't work in. That's a trapezoid. I have opposite sides are parallel and opposite sides are congruent. Okay, but that's not a parallelogram. So I had a contradicting example. So B is not enough information. Okay, this example may be parallelogram, but I don't have enough information. And in C, I said yes, because I can prove that both pairs of opposite sides are parallel. Okay, you got to think outside the box here. If you're given information, it's for a reason. Here I have 2 angles. They are congruent. They're also alternate interior angles. Alternate interior angles form that letter Z, even though it's sideways. And then we know that the sides they form with are parallel. So I could prove these 2 sides parallel. Okay, here's what I would like you to do. Flip back to the first page, please. On your own now, try to do it without looking at the notes. Read the notes over and then close them up. And I want you to try to fill in the 5 properties of the parallelogram, so number 1. And then also the minimum information needed to know if it is a parallelogram. So that is what we just talked about. Okay, if one pair is parallel and congruent, it means it's a parallelogram. So see if you can do those 2 pieces of information on your own without looking at your notes. See what you can remember. Do not worry about number 2 because you will learn how to do that in class. Do not just copy over for 1 and 3. If you're not sure, wait until you do more practice in class and then try to fill that in on your own. Okay, this information right here that you fill in is going to be helpful, a good way to condense all the information. All right, we are done for today.